Hey, I don't hear you.
Can you hear me now?
Yep, I can hear you now.
You can hear me now.
Welcome to Inventing Daily with Carolyn Kane. This is episode 11. Today's guest is Charles Koch, who's the owner of 3 Access Development, who does additive manufacturing, specializing in short-run manufacturing with fast turnaround. That sounds impressive.
Well, everybody's always trying to get somewhere quickly in this day and age. So, we do what we can.
That's true. Tell me how you got started in the business for the people that don't know you.
Well, I started out in the advertising world and I came down to Florida. And I guess about 20 years ago, somebody asked me to go look at their son's business, which had a garage in Pompano Beach with an SLA machine, which is called stereolithography, which was really the first technology in the 3D printing world that most people used in those days. Before that, people would cut a bar of soap or, take a piece of wood, whatever it took. But all of a sudden, with the advent of 3D CAD, people were able to, before it was called 3D printing, make 3D models of real things and evolve. And from there, we got involved in other applications for short-run manufacturing using 3D as a tool path.
How long ago was that when you started the actual making prototype type of work?
We're doing it about, I'm involved in it, although that's really just about the beginning, although I know it went a little earlier, about 20 years now.
Wow.
And the evolution that we've seen based on both the 3D process and the technology of the materials that come out of 3D machines are also jump-starting some of the things that clients may need for prototypes, whether it be a printed production part, a cast production part, or a molded part.
Okay. Now, we're involved mostly with inventors, but when an inventor comes and says, I want a short run of a widget, how do you decide how many to run on that? Is it a cost base, or how does that work?
Well, we have to ask some qualifying questions. First is, what are they going to do with the one or the prototype? Because remember, the words prototype mean not just the first one.
Right.
And a lot of times people don't gather what that means. Oh, yeah, it's my prototype. It's going to be right. It's not always right. That's why it's a prototype. It may be that you see it, you make it, and then it has to evolve a little more. So we make the decision if they've gone from patent to CAD drawings, we'll look at the different questions they answer regarding how they're going to really use it. Is it going to be a fit check model? Is it going to be an investor model? Are they going to take it and do field trials? There's a lot of choices. But so we have to ask these qualifying questions to help them get there. Because if they make one prototype and oh yeah, we're going to test it, and we pick the wrong material and they throw it at a wall thinking they're going to test it, and it shatters to oblivion, well, then we didn't give them the right advice because they didn't give us the right answer.
Or it could be that they didn't know the right answer. I mean,
well, that's true too. We're here to qualify.
Right. I know my first prototype was, I think, Rotocast, and when I opened the box, and it was not a cheap one. I knew as soon as I pulled it out that the measurements were wrong, and somehow I had miscalculated. Mm-hmm. And I knew before I even pulled the whole thing out that we'd have to do another one. And so it's a good thing, I guess, I only did one. Right. Because the failure was wrong.
And since the time that I think you did your first one, things have evolved. There are new machine technologies out there from the point of view of prototyping in 3D print that, we, in those days, the biggest part we could make was like 20 by 20, and it maybe took forever.
Right.
Well, now we've got 3D machines that over the course of a day can almost print that. Now, it depends again what you're trying to achieve with the materials. That affects the times on the machines. But what they can get out of prototypes now, people are printing and they're being used as production parts in some of the new technology printers.
Wow. And I know that a couple of my parts, when we were trying to figure out scale, um, a couple of them towards the end of it were I think not mass produced, but easily produced. So, but how do you give somebody questions about how they're going to use it and where it's going to go?
Mhm.
Um, with that being said, you're advising them what kind of material it should be.
Well, one of the things you have to be careful about is advising what the final material is. You might advise on materials based on what they're trying. Let's take it through the steps. If it's in the prototype process, depends on what they say they're going to do. If it's going to be a test, or for instance, this is stereolithography. It's a little enclosure, fit, form, and function, printed in a pretty liquid clear material. But this was used just for a fit check. That's it. Okay. Wanted to snap it together, make sure it fit, that it showed him everything he needed in his particular project. In other technologies that we have now, we have FDM. Well, in certain applications, FDM, this is just a little part that you wouldn't know what it does. Half the time, I never know what they do. People ask me to make things. But this is a very durable material. I mean, it always snaps in my hand.
What does FDM mean?
Fused, this was stereolithography, SLA. FDM is called fused deposition modeling.
Oh.
FDM is the process for prototyping that most people are familiar with now because of the home printers. It's a filament that builds layer by layer
Okay.
by layer. Okay?
Right.
And in certain circumstances, people are using this for production. However, you can't do a lot of things with like PSI pressure and things because it'll split apart. But if it's strictly strength or heat, great material, great process. And we can make, well, big parts, 24, 36, 24. There are machines using filament type materials that'll print 6 foot by 6 foot. They're more fragile, used more for a tool pattern. But in the seeming of way of how people are trying to achieve their goals, I don't know why I lost my camera. I apologize. Come back, come back. I want to apologize to your viewers.
We've
Well,
lost your
actually,
face.
it implies that my host, am I the host or are you the host?
I'm the host, so
It implies that it happened on your end.
didn't do anything. Let's see.
Let's see. Start video. Let's see if that works. There we go.
There you go. You're back. Yay.
Sorry, folks, for me walking away from you.
Oh, and you're gone.
I'm gone. Try again. I really don't know what's going on with that, but
that's okay. You're bouncing. So yeah. when I come to you and I say I need parts, and I need, let's say, I need 10 to send to different people to get ideas or maybe proof of concept or just feedback. And let's say the parts are as big as maybe a soda bottle, just to give a perspective. How small soda bottle? How long would that take? I think most of our viewers might not know that you'd need probably engineering drawings in order for somebody to manufacture that.
Well, in a sense, again, not engineering drawings, because then people would perceive it was the traditional 2D. They need 3D CAD solid models. Those 3D CAD solid models, basically you've seen 3D on your computer, like something floating in space. Well, what that does is it's almost like the 3D solid is the engineer's Microsoft Word. He gets a design, he puts it into the system, they project to the printers, and I'm really embarrassed that I keep losing you.
No, it's usually that's on my side. There you go.
Okay, there we go. Okay. And so 2 options if we were making a bottle. I might print it, like I showed you with that clear part. Bottles are usually, however, a blow process.
Right. So no, I was just thinking for scale. So if you had something that big, or, just to give our listeners a perspective, how, and you were doing, let's say I needed a dozen of them. Is
Okay,
that
one
something?
process.
Oh, okay. So let's say they were 3D printed.
Okay, well, we could 3D print them, is one process, but what we would probably do is a bottle, because we've done it for companies. We would print the bottles to halves. So we'd split it.
Okay.
Then we would glue them back together using if we did, we'd most likely do with SLA, because that's the clearest material. And then when we welded it back together, you do it with a laser, and then you polish it out, you almost don't see the line. So you could do it that way. Another option is a process called RTV casting. Okay, RTV casting uses an SLA master. Well, in this case, I'm showing you at the end, but a 3D model. We make rubber molds, and then we put the material into the mold, or we pour it in, and then we put it in a vacuum chamber, and it gives us a liquid clear part that can give me like 20 different pieces out of that tool. So
Oh,
that's one process by which, and I'm just trying to see if we have one here. Don't mind my tool chest.
so you're saying as if it was blow molded.
If it was a blow mold, but you didn't want to do the tooling, you could take
Oh, okay.
blow
Okay.
molding. No, most blow molders will never talk to you if you just want 10. It's not going to happen because the tool's too expensive.
I know.
So if you need to prototype it,
Oh,
then
okay.
more than likely print or cast it. For instance, again, what's happened in the 3D world, like this part right here, you can see it's like a lens. Okay, this
Right.
this was printed in what's called polyjet technology. It's almost liquid clear, and if it wasn't that the texture of the gradations in the light were there, they would look like a clear lens, and you can make 20 pieces. Again, different machines and different technologies also have variables in how big they can make. But if you can adjust, or if you can get your technology to give you the prototype parts, you can get into your short run that your inventor wants without having traditional tooling.
And hasn't tooling changed where it can be, instead of the ones that I had to have made in stainless, or in not stainless, maybe in an aluminum, where it's a lot less expensive? I know
Yes.
that was transitioning.
Again, it comes down to, let's say, volume, and in some cases, material. For instance, if you use an aluminum tool to print, many people want to use a liquid clear polycarb, which tends to be what people use for lenses. But in an aluminum tool, in some cases, you can't, even though the QC10s, which are very good, high-end, durable for higher volumes, you can't get them hot enough for that push on the liquid clear. Sometimes you get a little bit of a, excuse my hands, folks, a little bit of a wave. It'll just look a little imperfection in the clarity. That's why most liquid clear polymers are done in steel tools, so they can burn and flow.
Oh, well, the reason I was asking is if I'm trying to figure out if something, I'm not going to make parts to sell, but I'm going to make parts to send, to maybe get a purchase order, or maybe to go for some kind of licensing deal where it's been, they can see it, touch it, feel it, and see how the product's actually going to work. Because the end manufacturer, or the person that's going to license it, is probably going to have some kind of tweaks to it, or something that they want to add or change. But if I wanted to just get enough parts to proof of concept and finish out those details that were screwed up in the first 3 prototypes, that's something that would take probably how long? You're saying
you can get aluminum tools and parts in your hand in 2 to 3 weeks.
2 to 3 weeks now. Wow.
There are processes that are even faster depending on the company. But in general, with aluminum tooling, you're going to quote 2 to 3 weeks, which is about, you'd say 10 or 15 business days.
Do you
But
have
I mean,
any? Do you have
yeah.
any companies that are in the U.S.? I mean, I knew there used to be a lot in Michigan, but that make that kind of tooling.
Yes, you have companies like Xometry, companies like Protomold, and
Oh,
there's a new player out there well, not a new player, but they're changing their model, called eccentric.
So if
They
somebody,
aren't eccentric, they just eccentric.
oh, okay. So if somebody, obviously in the world that we live in, a lot of people want to bring manufacturing home as opposed to sending it overseas. So you have enough companies that you could do that with, and are they more expensive?
No, well, everything's relative. Okay.
Yes.
If you go to China or some of the other countries, you're going to have a couple of risks. One, they traditionally don't do short. They're starting to do more and more short run, but that's really, well, I can't say this on TV. They, you have to be cautious
Okay.
because of your concept and your idea. In some countries, they might, you know, borrow your thoughts, for whatever that means. But in the US, you're looking at two things. When you want a short run and you can do three, well, you can only get it three ways: price, time, and quality.
Right.
But you can't have all three. So if your goal is to get a short run for either leveraging your manufacturing, bridging your manufacturing, you might pay more on the piece price, and you're going to buy an aluminum tool versus a steel tool to get the time. So that tool is going to have a certain life, where if some of the offshore tooling, they'll guarantee 1 million, 2, 3 million parts because they just throw the labor at it.
Well, but don't you think, and we've both been in this long enough to know that it might be that you only want to get 1,000 pieces.
Then it's a domestic project, no matter
And
what.
then, yeah. And then whoever's going to license or change they might change it or change the look or something about it. They're going to have to retool it anyway.
Right. They may apply, you may have done something and you show them the concept, you show them the idea, and then one of their marketing people says, if we put an ID guy on this, because remember, people use industrial design. We like to jokingly say to make a part sexy and its utility, but we use mechanical design to make it manufacturable. And those two things can sometimes be apart.
Right.
Most people don't usually have the money for an ID company, so they're going to basically make their project from a mechanical point of view. So when you look at it from that direction, pretty much you're going to stay domestic in some format to get to your first steps. Because to go offshore and have to do the late night communication with another country or another part of the world, and you're not used to it, and there's a syntax issues, you're probably better off staying domestic if you're just going to do the first 100, 500, 5,000.
And the companies that you've dealt with, obviously you have built a reputation, and you've got, you work with them often enough that you know who to send the parts to or who to work with. So if I brought you a tool that was for, let's say, a metal tool, maybe a screwdriver or a new handheld tool,
Right.
you have the right company that you have a relationship with.
Oh, absolutely. Here, this is a world famous brand name, DeWalt. These were made by a company I work with who used to do all the prototype molding, and to a degree still does, but more so in the past, for Black & Decker, DeWalt, all these brands, because they didn't want to go offshore right away. But sometimes they wanted to get 1,000, even up to 5,000 parts out so they could send them to the buyers. They could give them to their sales reps. And for all intents and purposes, it was made the same way. It was injection molded with a nylon-based material. And then they used a TPE, which is called a thermoplastic elastomer, as an overmold, a grip. And they made them all here in the States. And then all they did was insert the metal screwdriver, and they had sample parts to show.
I guess that's exactly what I was asking, because when you're new or you've got a new product and you don't know, first of all, you don't know if it's going to make it in the market, or if it makes it in the market, if somebody's not going to knock it off before you've sold your 100,000 parts. It still makes sense to me to go with a lower volume, even though you're going to pay more per piece. I mean,
very true, and good advice to your viewers, because all too often people jump into a tool somehow, more of a production device, they get their numbers, and then whether the product went flat or whether the client came back to the purveyor of the new idea and said, "Hey, I really like it, but you gotta, take this side off and make this flat." I'm just showing a part to do that, but all too often you run into that.
And then you've spent thousands and thousands on the tooling, and it's wrong, and it's got to be retooled.
Right, because remember, once you cut a tool, it's very difficult to put the metal back. So
Right.
you've made that expense, you've made that commitment, and all of a sudden you're on a path that you cannot fix, and you've got to reinvest.
I think a lot of inventors see a cost per piece. So let's say if you made 5,000 pieces for me, they're going to cost $1 a piece.
Okay.
But if you make 20,000, they're going to be 50 cents a piece.
Okay,
and they want that lower cost.
Volume, there's discount.
But they don't even have an outlet for those 20,000 pieces. So I don't know what they've gained. It's just they see that 50 cents as opposed to $1, and it makes them nervous.
Well, that's why so often many inventors fall into the trap of going offshore because the tooling is cheap.
Right.
And I don't mean any disrespect to inventors, but the tooling is cheap and my piece price is cheap. And again, there's two risks to that. You might have a great idea. Somebody perceptually likes it. Whether you have a patent or not, may or may not. At least if you start off domestically in the United States and try to bring it to market at a certain level or use it as your leverage to go to your buyers, you can, if even without an international patent, which doesn't protect you as much, but at least you've gone to some tooling and gotten the concept sold. Because if you've done the quotes in some other country as well, you know your time frame, unless you hit one of the big national holidays they have. So you're going to know that offshore, if I do it, depending on the country, it's going to take me 7 to 8 weeks, 9 weeks sometimes, depending on how many cavities, maybe more, to get parts shipped back to the United States. So you could always tell your client, then, yeah, we can make delivery starting on this date. But again, what happens with many inventors is they don't want to do the double hit on the tooling. Right. So they're going to just do the one hit once, and then they're going to hope for the best.
And yes, that is what inventors try and do.
Well, and look, an invention is a growth of an idea that a person had, whether it was playing with their deck, working in the mirror, driving along and saying, gosh, this could be better. And that's how it happens in most of the cases. Many people have some deep thought about it. I'm not making that everybody just goes piff with an epiphany, but the inventor has to be realistic about their expectations for 2 or 3 things. 1, what are going to be my true costs to get there? 2, am I going to test it or try to go right to a market, or am I going to go to royalties? And 3, what am I willing to spend to get parts on a shelf or on land, so to speak, so that they can be leveraged as a real product and marketed appropriately?
Well, those are all steps that I do try and coach inventors, and you have to think about that up front. You can't just say, I need 1,000 pieces. Well, what are you going to do with those 1,000 pieces? And who's going to use it? And like you said, how is it going to be used? Are people going to test with it? Or one of my...
Or are you going to sell them? Or people are going to just say, hey, I want it now. Move, boom. And, we've seen many inventions over time. Some great ones, some moderate, some that were great inventions, but they were 3 months too late and a new technology came out. You just don't know.
Right.
It's excuse my language, it's this side of a crapshoot sometimes. But there just has to be formative thought put into it by any inventor about my idea, my marketing and financial budget, and how I'm going to leverage that to become a brand.
Well, but, with Shark Tank and with a lot of these things, people think they're going to be an instant success. I was at the Shark Tank auditions in Miami, and I saw a gentleman who had a tool that he had made. He had won, and I had seen it 3 years before. And he still thought, I said, have you made any samples? Has anybody tested it? Have you done anything with it? No, they're going to love it. I'm going to get on Shark Tank. And he had no concept of all the other pieces that had to fit together. And he was convinced, and there was nothing I could say to him to convince him that he should have done a little bit more.
You know, Shark Tank has created a myriad of mental pathways for inventors.
Right.
It is between reality and a hope and a prayer. And most people don't even understand what you have to give up if you win. But that's okay, because you
or
figure,
if you're just on. There's
beyond, there's a cost. But I think that from the perspective that I'm at least expressing today, and I think you're trying to offer, just really the inventor has to have some serious thought about what is his or her budget and how he or she is going to plan to do their marketing, and also to get their product ready for people to accept and utilize.
And the process we're talking about isn't just for inventors. You do this for all the companies that you deal with too, right?
Oh, absolutely. There are times I've worked with companies, and I ask the question, you know, because I've worked with some companies that were manufacturing startups, technology startups. And it was like when you first went and worked with them, you had to ask them, well, who's the target market? How are you perceptually going to get this thing to happen? And, you know, in the world today of internet marketing and internet manufacturing, things are changing like woof. And you have to be able to figure out the next path. And especially given the times we're in with COVID and so on and so forth, a lot of the traditional ways of leveraging your parts or your product or any technology are going to change for the foreseeable future.
So with that being said, we're doing this, you know, on the internet. You can deal with people just the way we're dealing. I mean, you can look at parts and drawings and have discussions with people instead of meeting them in person. I mean, I know you and I met in person several times with over a couple of my products, but it's changed. So you can't always get that feel. So I think those prototypes are even more important to convey what you're trying to express in what it does or how it does.
Well, the nice thing about it is with the speed, if at least if you're going, if you're going with any of the 3D technologies, with that speed that some of these machines print at these days, a client potentially could order 2 models, or I could order 2 models for them, ship them one. I have one, and we're sitting here and, excuse my, you know, this is the same part twice. They have one, I have one.
Right.
We're talking about what changes do you want to make. I listen to that, and then what I'll say to them is, okay, I get it. Mark up your model, even though I might write things on this one, but mark up your model so perceptually I'm very clear on what it is you told me. Although with this spontaneous video now, it's pretty seamless. And I think that from that perspective, we can make whatever changes need to be made. And whether you do another set of 3Ds or not, you're going to be pretty close to what the person's trying to achieve.
So what do you think inventors need to know, or what questions should they be asking themselves before they call somebody like you? What are a couple of the questions?
Again, one of the ones I stated is, what am I willing to spend to get, not necessarily to market, just to get so I have a holdable product that I can evaluate. 2, am I going to use it to test either myself? I don't mean testing yourself, so, you know, hitting yourself with anything, but test it myself, or give some samples to people to almost like taste, you know, get a taste for it, and then get their remarks towards your changes. And then potentially figure out what your costs are and go to viable vendors to get the costs. And, you know, you can get 1 or 2, you can get 3 vendor costs unless you know somebody personally who you've been referred to, which is how I get a lot of good business too. Because
Wait, well, wait, back up vendor costs for,
well, your vendor costs. What are you might get 3 vendors to give you a quote, so you know what
oh,
your
okay,
costs are to make it.
to manufacture it. Okay.
Manufactured, correct.
So that's one way to do it. The other way might be to do it backwards. So take your product, you've seen something similar on the market. Can you even compete with that price? And you'd still have to do the same things. You'd still have to.
Right. You could evaluate your part or your product, see what they're selling it for. But until you know, like for instance, some of the variables that we haven't even really covered, is the part just parts, i.e., is it just a plastic box? Okay, a plain plastic box, or does it have a lot of electronics in it? We haven't even covered circuit boards, electrical wiring.
Oh, we're going to come back to that another day.
I know, but what I'm trying to share with
Yeah.
you is it depends on what it is again, we went back into this earlier. What are you making? How's it being used? And what does it entail for you to achieve that goal?
Right. So you have to know all of those things. So what are you going to, how much are you willing to spend to get, let's say, that prototype? Are you using it for testing or focus groups or licensing? So you could send that to, that vendor costs, and then probably market studies. You still have to do market studies and see if
Yeah,
any.
you have to know who wants to buy it. You have
Yeah.
to know who the customer is. There are in a lot of different industries today. There are people introducing products and they don't necessarily even understand their market. And when you get involved in marketing a product or creating a product that might even have the ability to be its own brand, which is really how you want to look at a product if you introduce it. You might either be a category product, an also ran, or you might be a cutting edge product that creates a new brand direction. You really need to understand who the customers are. Some industries market a certain way up and down the line, no matter who they are. And in some cases, it may behoove certain companies to pick a new direction within the realm of their category because nobody's looking at it that way. It's sort of like a fresh look, beyond the box, so to speak.
Right.
But I think that it's really up to the manufacturer or your client or inventor client to really sit down and evaluate not all the things we've talked about. How do I make it? What are my costs and how am I going to market it? Because all those processes add up to a cost. And it all comes also down to time. Sometimes people come up with a good idea. I want to get it out by Christmas because it's just going to blow up if I can do that. Well, what is it going to take to do that? You may think you've got everything in line, but all of a sudden there's a glitch in your circuitry or something. So you really need to have your plan in place from the prototype on through to let's call it the light production, so that you can be successful when you finally launch.
So true. There's so many moving parts to this.
Absolutely, Carolyn. I mean, you and I have worked on projects and we've seen a lot of projects, and you try to give the best advice how from your experience, and hope that the customer / inventor appreciates it. You're not, you're there to make a dollar. That's our business, but we can only hopefully give good advice so that we make the dollar not just once but many times, as do we want them to, by following a pathway that we hopefully lay out for them that makes sense based on our experience. We're not always right, but after you do it more than 10 or 20 times over time, you get a sort of sense for what has to be done.
Right. And the inventor has to be open to listening to the advice as well. I mean, a lot of times they've decided it's going to go a certain way, and that's all they'll have, and that's okay. That's their choice. Well, Charlie, tell me how people can contact you.
They can go to my website, which is www.3axis.us, or you can call my 2 numbers, my office number, 561 752-9095, or my cell, except for late hours, 561-504-5400.
Okay. Good. Those will be, I'll put those, all that contact information in the notes.
Great.
And thank you for joining us. I think this has
It was
been,
my pleasure. I actually like doing this stuff.
I do too. I'm learning and getting better at it as we go.
Yeah, it's an interesting thing to. I do a lot of my own videos for my own company website, and I had one or two guys once say to me, "said You don't use a script," and I said, "No," and I said, "You shouldn't have to if you know your product."
Right.
And I think I know my product, and I like what I do, so we try to help people where we can.
And, absolutely. So if you have any more questions or you'd like to be a guest on the show, you can email me at carolyn@inventingdaily.com. And please follow us on YouTube. And I'm going to put the link for this podcast in there as well in the notes, along with Charlie's information. And as always, keep inventing daily. Thanks,
Have a great
Charlie.
day. And by the way, folks, you're in good hands
Thanks.
with Carolyn. Not me too. Have a good night.